Assalamu alaikum. We were discussing the various kinds of operators in C language, and in this video we are going to discuss the assignment operators in C. Let's begin. So what are these assignment operators? The simple assignment operator, as you can see, is denoted by this is equal to sign, which we are quite familiar with, but this is quite different from the way we see it in mathematics. In mathematics, we use this to signify some sort of equations or inequalities. But in C programming, this is a completely different entity and it works in a completely different manner. So what does this assignment operator do? So it works on two operands. One on the left, as you can see the operand 1, and one on the right of this assignment operator, as you can see the operand 2. So what does this operator do? Whatever is present on the right side of this assignment operator, this could be a value, an integer, or anything, or maybe another variable. We just use the term operand for this thing. Whatever this thing is, it gets assigned to whatever is present on the left side of this assignment operator, which usually in most cases is a variable. So if we have something which we want to assign to a variable, we want to assign some value or whatever to something, we can use the assignment operator. However, the assignment operator also has its types and variants, which we will see later on in this video. But the first thing which we need to understand and get out of our way is that this is not the same is equal to sign as we are familiar with in mathematics. This is the assignment operator. So we are going to call it by this name. And one more thing to clear this thing up, the statement x equals to x plus 1. In mathematics, this kind of statement is not acceptable at all. However, in C programming, this statement is very much valid. So what does this mean? So it means that whatever is on the right side of this assignment operator, which is x plus 1, gets assigned into x. If x previously had the value 8, then now x will have the value 8 plus 1, and it will be 9. So 9 will be assigned to x. So that's what this means. So now let's have a look at the different kinds of assignment operators in C. We can have a look through this table. So there are various kinds of assignment operators which we will use, and we will briefly go through all of these and then we will discuss each of them in detail. So first of all, we have the simple assignment operator which we just discussed. Similarly, we have the add and assignment operator. Similarly, we have the subtract and assignment operator, multiply and assignment operator, divide and assignment operator, modulus and assignment operator, left shift and assignment operator, right shift and assignment operator, bitwise and assignment operator, bitwise exclusive OR and assignment operator, bitwise inclusive OR and assignment operator. So let's have a look at each of these operators and discuss them in detail. So let's see the simple assignment operator. So this is denoted by this traditional is equal to sign, and whatever is on the right side, we denote this as operand 2. This will get assigned into this operand 1. In other words, the operand on the right side gets assigned to the operand on the left side. So let's try to understand this using an example. In this program, I first declared an integer variable x, and then I print a message that the value of this x before using the assignment operator is such and such, and then I assign the value 10, which is an integer, into this variable x using the assignment operator, and then I print a message again that the value of this operator after assigning some value into this is such and such. So let's see. So first of all, this shows that the value of x before using the simple assignment operator is 0 because I just declared it without assigning anything to it. So the compiler just gave it a value of 0, and after I assigned the value of 10 into this x using the assignment operator, it shows that the value of this variable is 10. So this is quite simple stuff. So let's move forward. So now let's have a look at the add and assignment operator. So as you can see, in this operator we have the plus sign, then the equal to sign. So what does this operator do? Whatever is present on the right side of the operator y, it adds this thing to whatever is present on the left side of this operator, which is z. So now we have this thing y plus z. This thing gets assigned to z. So you get the point, right? For example, if z originally carried the value 10 and y carried the value 5, so what would this thing mean? It would mean that add z and y, and after we add them, assign this result into z. So what was the previous value of z? It was 10, and y is already 5, so this thing is equal to 15, and this 15 gets assigned into this z. So the new value of z is 15. So this is how this operator works. This thing, z, add and assignment operator, is the same thing as z assign z plus y. If you feel that you are confused, let's try to understand this thing using an example. In this program, I first declared an integer x without assigning any value to it. Then I printed its value. Then I used the add and assignment operator with the right operand being 10. Then I print the value. Then I again use the add and assignment operator with the right operand being 20. And then I print the value. So let's see what the result comes out to be. So as you can see, first, since I declared the integer x without assigning anything to it, it just gives out the value 0. And after that, I use the add and assignment operator, which is equivalent to x equals to x plus 10. So since x had the value 0 at that time, so it's equal to 0 plus 10, so it shows me a 10. Then I again use the add and assignment operator. So it's the same thing as x assign x plus 20. So the x carried the value 10 at that time. So it was equal to 10 plus 20, which gave me a 30. So now you might have an idea how this thing works. So let's move forward. So now let's have a look at the subtract and assignment operator, which is denoted as this in a subtraction sign, then the simple assignment operator. So what does this thing do? So imagine I have an operand z, and then I apply the subtract and assignment operator with the right operand being x. So what this operator will do, whatever the value of the operand on the right side of the operator is, which is x, it will subtract that thing from whatever is present on the left side of the operand, which is z, and this result will ultimately be assigned into this z. So how do we understand that? For example, z originally carried a value of 10 and x carried a value 3. So what this operator is equivalent to, it's equivalent to z assign z minus x. So this right operand, we subtract that from the left operand, and whatever the result is, we store this thing into z. So it will be 10, which is z, minus 3, which comes out to be 7, and this 7 will be stored into z. So let's use a C program to understand this better. So as you can see in this C program, I've declared a integer variable and assigned 100 into it. Then I print the value, and then I use the subtract and assignment operator with the right operand being 10. I print the value, and then I use the subtract and assignment operator once again with the right operand being 20 this time. So what will be the values? Let's have a look. So as you can see, first it simply prints out the original value which I had assigned, which is 100. Then we use the subtract and assignment operator, which is the same thing as x assign x minus 10. So what value did x carry at that time? It was 100. So when you take away this 10 from 100, you get a 90. And then we use the subtract and assignment operator once again. And what happens? This right operand 20 is subtracted from the left operand, the previous value of this left operand, which was 90 at that time, and after taking away 20 from it, we get a 70, which gets assigned into this x, and after printing its value, we get a 70. So this is how the subtract and assignment operator works. Let's move forward. Now let's have a look at the multiply and assignment operator. So this thing is denoted by this star symbol followed by the traditional equal to symbol. So what does this operator do? For example, we have the left operand as z once again, and then we use the multiply and assignment operator on this thing, and the right operand will be x. So whatever is present on the right side of this operator x, it will be multiplied to whatever is present on the left side, which is z. So let's use this star symbol, and this whole result, it will be assigned into this z right here. This thing is equivalent to z assign z multiplied by this x. So let's try to understand this. If z carried a value of 9 and x happened to carry a value of 8, so what would be assigned in z after applying this multiply and assignment operator? These two would be multiplied, so the result obtained would be 72, and then this 72 would be assigned in this z. So let's use a C program example to understand this better. So let's see. First I declared two variables z and x, which are of the type integer. Then I assigned the value 9 into z. So let's assign 8 here for simplicity. I assigned 8 into x and 9 into z. Then I printed the two values, and then I used the multiply and assignment operator, which stores some value in z, and then I printed both values again. So let's have a look at the output. So as you can clearly see, here I haven't built it yet. So yeah, now as you can clearly see, first the value of z and x get printed, which are 9 and 8 respectively. Then I use the multiply and assignment operator, and this thing is equivalent to z assign z multiplied with this x. And when I print the values of both these variables, after that I get a 72 and the 8. So 72 has been assigned in z, and the 8, which was previously assigned in x, remains unaffected because I did not apply any operator on x after that. So this is how the multiply and assignment operator works. Let's move forward. So now let's have a look at the divide and assignment operator. So it's denoted by this slash followed by the traditional equal to sign. So let's have a look at what this operator does. So let the left operand be again z and the right operand be x, and in the middle we apply the divide and assignment operator. So what will happen? First of all, we need to understand that this is equivalent to z assign z divided by x. So whatever is present on the left side of the operator, which is z in this case, gets divided with whatever is present on the right side of the operator, which is x, and that thing, this whole thing, gets assigned into z. So for example, z carries a value of 8 and x carries a value of 4. So when I apply this divide and assignment operator, z divide and assign x, so this z gets divided by x, which gives us 8 by 4, which is 2. Let me write it here. And this 2 ultimately gets assigned into z. So this is how the divide and assignment operator works. Let's try to understand this with an example. So as you can see, again I have declared two variables z and x. I have assigned the value of 100 in z and the value of 50 in x. I print both these variables, and after that I use the divide and assignment operator on z with the right operand being x, and then I print both the values once again. So let's run. So as you can clearly see, first I get a value of 100 and 50, which are the respective values which I had assigned in z and x. After applying the divide and assignment operator on z, this thing is equivalent to z by x. This z by x, which is 100 by 50, gets assigned into z. So 100 by 50 is 2, and this 2 gets assigned into z and is therefore printed out. However, what should be noted is that the value of x remains unaffected. As it was previously assigned the value of 50, it still retains its value. So only what is present on the left side of the divide and assignment operator changes. So this was the divide and assignment operator. Hope you understood this. Let's move forward. So now let's have a look at the modulus and assignment operator. This is noted by this percentage sign followed by the traditional is equal to sign. But before looking at the modulus and assignment operator, let's look at what the modulus operator does. So this basically gives us the remainder when we apply it on two operands. For example, we apply 9 modulus 2. So then you simply divide 9 by 2 and you get a remainder 1. So this remainder is the output of this operator, which is 1. So this is what the modulus operator does. With that being said, let's go through this modulus and assignment operator For example, we have two operands, one on the left and one on the right, z and x, and we have applied the modulus and assignment operator. So what will happen? This z will be divided by x, and let's say we get some remainder y, and this remainder which we get will be stored in this z. For example, if we have 80 and we apply the modulus and assignment operator, and on the right hand side of this operator we have 30, then what will happen? What's on the left, which is 80, z, will get divided by this 30, which is x, and then we'll get 20, and this 20 will be stored in z, because we had assigned the value 80 to z and the value 30 to x. So this remainder will be stored in z. So let's use an example to understand this better. So as you can see, we have declared two variables, z and x, in this program. We have assigned the value 100 into z and the value 30 into x. Then we print the values of both these variables, and after that we apply the modulus and assignment operator on z, with the operand on the right hand side being x. So what will happen? Simply this is equivalent to z assigned z modulus x. Then what will happen? Z will be divided by x and the remainder will be stored in z, and then we print both these values once again. So let's run this program. So as you can see, clearly we get two values, 100 and 30, which were the respective values that we had assigned in z and x respectively. After that we apply the modulus and assignment operator on z with x on the right. So this 100 gets divided by 100, which is z, gets divided by 30, and the remainder is 10, and this thing gets assigned into z, and as you can see, the value 10 gets printed. However, it must be noted that the value of x, which was 30, remains unaffected. So this was the modulus and assignment operator. Hope you understood this. Let's move forward. And now we are left with the right shift and assignment operator and the left shift and assignment operator. So let's discuss both of these together. So the right shift and assignment operator is denoted by these two angular braces and then the equal to sign. And the left shift and assignment operator is denoted by the starting angular braces and this equal to sign. So what do these operators do? Let's discuss. So for example, we have an operand 1. We have the first operand, then we apply the right shift and assignment operator, and then on the right side we have operand 2. So what happens is that the binary code of this operand 1 gets shifted rightwards. So it gets shifted towards the right by a factor of this second operand, which can be a number. It can be 2, 3, 4, 5 or anything, and whatever the result we get, it gets stored into this first operand. So let's try to understand this. For example, we apply the right shift and assignment operator on 15. So I take 15 and apply the right shift and assignment operator on this. And by what factor do I want to shift this? Let's say it's 2. What will happen is that we see the binary code of 15, which is 1 1 1 1. So how is this? It's 2 raised to 0. You know these things now. 1 and 2. So this comes out to be 8, 4, 2 and 1. Then you add this, so you get 15. So let's not get into those details. So what will happen that this whole thing 1 1 1 1 will get shifted 2 steps towards the right. Alright, so when this whole thing gets shifted towards the right, we get 2 vacancies and these 2 ones will be discarded. So what we'll get is 1 1, which are these 2 ones, and these 2 have been shifted towards the right, so they are discarded, and the remaining vacancies are filled with zeros. So we get 2 zeros because we gave it a right shift of 2. So whatever this thing is, this gets stored to this variable which contains 15. So and the value of this 0 0 1 1 is 3. So for example, let's try to understand it like that. I applied x right shift assignment y, and x was assigned the value 15 initially and y contained the value 2. So after that, what will happen is the same case as we discussed here. 15, which is in binary 1111, gets a rightward shift by 2 steps, and those 2 vacancies are filled by 0, which is 0011, which is 3. So this 3 will get assigned in X, and ultimately 3 will get assigned in X. So that's it for the right shift and assignment operator. Now let's have a look at the left shift and assignment operator. So for example, we apply the left shift and assignment operator on this Z, and by a factor of 2. So let's say Z was assigned the value 15 initially. So again we take the binary of this Z. Since Z is 15, so 15 in binary is 1111. We'll take the same example. Now the difference here is that it will get a leftward shift by 2 steps, and all of these 4 bits will be shifted towards the left, 1 1 1 1. The difference is that none of them will be discarded, which was not the case with the right shift. So I gave it a leftward shift by 2 steps, and these 2 vacancies created will be filled by 2 zeros. So now this new thing, which is 111100, will be assigned in this Z, and this 111100 is in decimal, it's equivalent to 60. So 60 will be assigned in Z. So now you have to remember the difference between the right shift and the left shift operator, which are bitwise operators. We have already discussed these two, but here we are discussing the assignment operators. So let's not get into those details. So this is how these left shift and assignment and right shift and assignment operators work. Let's look at an example. So in this program, as you can clearly see, I have declared an integer z. I assigned 15 into this z. Then I print the value simply. After that, I give z a rightward shift of 2. So all of these bits will be shifted rightwards by 2 steps, and the vacancies created will be filled with 0. 2 bits will be discarded. After that, I print the value of this rightward shifted z. Then I assign 15 again into z to get the initial condition back, and then I give it a leftward shift by 2 steps. So here no bits will be discarded, and the 2 new vacancies will be filled with 0. So let's look at the output, and I print this thing again. So let's look at. So as you can see, first simply z in which 15 was assigned gets printed. Then after giving the rightward shift by 2 steps, we get a 3. After that, we assign 15 again in z. Then we give it a leftward shift by 2 steps, and thus we get a 60, as we saw in our example here. So this was it for the right shift and assignment operator and the left shift and assignment operator. Let's move forward. And now we are left with the bitwise and assignment operator, the bitwise exclusive OR and assignment operator, and the bitwise inclusive OR and assignment operator. We'll discuss all three of these together. So what do these operators do? Let's have a look. So the bitwise and assignment operator is simply denoted by this ampersand symbol followed by the equal to sign. So what does this do? Whatever is present on the left and right of the bitwise and assignment operator, the AND operator gets implemented on these two operands. Let's say we have x on the left and y on the right, so we get x and y, and whatever the outcome is gets stored in this x because it's on the left. So let's go into some details. For example, x was assigned the value of 15 and y was assigned the value of 3. Then we applied the bitwise and assignment operator. What will happen? First of all, what's the binary equivalent of 15? It's 1 1 1 1, and the binary equivalent of 3 is 0 0 1 1. Now x and y will be calculated. So how does the AND operator work? It returns a 1 only when both the bits are 1. It returns 1 when both the bits are 1. So here it will return a 1 1, and on the remaining bits it will return a 0 because only one of the bits is 1. So 0 0 1 1, the decimal equivalent of 0 0 1 1 is 3. So this 3 will get assigned in x because it's on the left. So that's what happens with the bitwise and assignment operator. Then we have the bitwise exclusive OR and assignment operator. So we had already discussed this exclusive OR or XOR operator in the bitwise operators, and we already know that this returns a 1 if and only if only one of the operands is 1. So If one operand is 1 and the other is 0, it will return a 1. And for all the other combinations, it will return a 0. So this is how the XOR or exclusive OR operator works. So for example, X carries the value 15 and again Y carries the value of 3. And we apply the bitwise exclusive OR and assignment operator on these two operands as this. So what's going to happen? The XOR operator or exclusive OR operator will be applied on these two operands X XOR Y, and whatever the outcome is will get stored in this X. So what will happen? For example, let's apply the XOR operator. 15 in binary is 1111 and 3 again in binary is 0011. Since we have applied the exclusive OR and assignment operator, so a 1 will be returned only when one of the bit is 1. So here we will get a 1 and also 1, and the remaining two bits will get a 0, because here both the bits are 1, which is not the condition. So 1100, the decimal equivalent of this is 12. So this 12 will get assigned into X because it was on the left. Similarly, we have the bitwise inclusive OR and assignment operator. So the inclusive OR operator we are already familiar with. It returns a 1 only if one of the bits is 1. And it returns a 1 even if both of the bits are 1, because our conditions are being satisfied. So let's apply this to the same example. For example, S has been assigned the value of 15 once again. Y has been assigned a 3. And then we apply the bitwise inclusive OR and assignment operator. On the left we have the operand X, on the right we have Y. So what will happen? The bitwise inclusive OR bitwise OR operator will be applied on X and Y, and whatever the outcome is will be stored in this X. So let's apply. The binary equivalent of 15 is 1111 and the binary equivalent of 3 is 0011. So as per the OR operator, it will return 1 for all the bits, because our condition of at least one 1 being present has been satisfied, and the decimal equivalent of 1111 is 15, which was the original value, and this will get assigned into X. So let's confirm this with the program. In this program, I have declared an integer variable Z, which has been assigned a value 15, and I have applied all of these operators: the bitwise and assignment operator, the bitwise exclusive OR and assignment operator, and the bitwise inclusive OR and assignment operator. To set the initial conditions back to their place, I have assigned 15 back to back in Z, and let's see what the output is. As clearly you can see, we get a 3, 12 and 15. The 3, 12 and 15, which was the same thing which we got here, the 3, 12 and 15. So this was it for our assignment operators in C. We discussed the assignment operator, the simple one, and all the other variants of it. That's it for today. I hope you found this video useful. Unfortunately, if you didn't, leave a dislike. Thank you.